here the terms given, the numbers given are not increasing by a sum. They are not basically getting added or plus या minus नहीं हो रहा है. Okay, the terms are getting multiplied by a constant value. So if you can observe carefully, यहाँ पे 1 is getting multiplied by 3, 3 gets multiplied by 3 to give you 9. Okay, 9 gets multiplied by 3 to give you 7. So the terms are basically increasing by a constant factor. They are being multiplied by a constant factor. Okay, so you may also observe that you can reverse the sequence. You can take 729 as the biggest term, and then you can basically divide every term with 3. Okay guys, dividing everything with 3 is as good as multiplying by 1 by 3. Okay, so such a sequence where the terms are either increasing or decreasing by a constant factor, it is called as a geometric progression. Okay, and let's understand the specifics. So what I have here is, I have a first term. Let's say 1 is the first term over here. उसको मैंने 3 से multiply किया, right? So into 3 हो गया. I got 3, the second term. Okay, to get the third term, I'll again multiply it with 3, right? So I have 1 into 3 into 3, दो बार. To get the fourth term, I'll again multiply by 3. So 1 into 3 into 3 into 3, 3 bar. Again multiplied with 3 times into 3, right? So if you take the first term as, let's say, A, and if you take this constant factor to be equal to R, the first term is A, second term is A into R, third term is AR square, fourth term is AR cube. ऐसा करते करते guys, you can observe the nth term will simply be equal to A R raised to n minus 1. Okay guys, this A is the first term, just like the AP. Okay, this A is the first term, and this R is the common ratio. Okay, R is the common ratio, A is the first term here, right? And you can remember the nth term as A times R raised to n minus 1. Okay, now let's talk about the sum. Okay, sum of the n terms of a geometric progression. Okay, for that guys, we need one formula which we have already discussed, okay, in the starting of the third module. Okay, A raised to n minus B raised to n. Yes, we have seen this formula already in algebraic equations ka second part, I guess. So A minus B into A raised to n minus 1 plus A raised to n minus 2 into B raised to 1, A raised to n minus 3 into B square. Okay, up to A raised to 1, B raised to n minus 2 plus B raised to n minus 1. Okay, this is how it goes. Okay, now in this guys, what we'll do is we'll substitute A ka value as R and B ka value as 1. Okay, so now when you do that, you can simplify this entire equation as R raised to n minus 1. Okay, on the left hand side, and on the right you have R minus 1 multiplied by R raised to n minus 1 plus R raised to n minus 2, R raised to n minus 3, R raised to n minus 4 up to R cube, R square, R raised to 1 plus 1. Okay, now you take the R minus 1 term on the left hand side, niche. Okay, and this is what you will get. Okay, and now I will multiply both sides by A. Okay, when you do that, I will have the right hand side as what? A plus AR raised to 1 plus AR square plus AR cube up to AR raised to n minus 2 and AR raised to n minus 1. Guys, अगर A अपना first term है and R is the common ratio, ये अपना पहला term हुआ GP का, ये second term है geometric progression का, उसके third term होगा, fourth term, fifth term, ये n minus 1 और ये nth term है, right? So guys, what do you have on the right hand side is nothing but the sum of the n terms of a geometric progression, right? So there is a ready-made formula now which we have for this sum of the n terms of a geometric progression, that is A times R raised to n minus 1 divided by R minus 1. Okay, so you can remember this formula also as such, the sum of the n terms of a geometric progression, A times R raised to n minus 1 divided by R minus 1. That's what we have. Okay, now we'll apply this formula guys. Okay, and let's observe, I have two kinds of GPs or geometric progressions here, right? First is when the terms are increasing by 3 every time, na factor 3 se increase ho raha hai every time, right? And the second time you are basically multiplying by a 1 by 3. Okay, 1 by 3 se multiply ho raha hai sara sequence, so numbers are reducing, isn't it? Okay, so I have two types of geometric progressions guys, basically the first type and second type. The first type is called as the diverging geometric progression. यहाँ पे the common ratio or the factor जिसे हम multiply कर रहे हैं, it is more than 1. Okay, 1 से बड़ा होगा तो जाहिर सी बात है कि when the numbers are getting multiplied by that factor, okay, the numbers will keep on increasing, right? Vice versa, if you talk about converging geometric progression, the second type, the common ratio will lie between 0 to 1. Okay, so as you can observe here, the common ratio is 1 by 3 and the terms are getting reduced by 1 by 3, right? 1 by 3, 1 by 3 every time it's becoming. Okay, so now guys, अगर मैं बोलता हूं मुझे इस ऊपर वाले geometric progression के सारे terms को add करना है, I want to add all the terms possible. Okay, well that won't be possible because that since you're multiplying by a constant value every time, okay, the numbers will be very very huge. आगे जाके अभी 729 दिख रहा होगा आपको, उसके बाद 3 से multiply करेंगे तो क्या हो जाएगा 2187, उसको 3 से multiply करेंगे 6561 into 3 into 3, so it will become a very big number, right? okay, so the nth term, okay, after a very large value of n, let's say, okay, जो बहुत आगे के terms होंगे वो तो काफी बड़े होंगे, right? So the finite number of terms also would be close to a very big value, right? So and that will basically keep on increasing, right? So in this case, it is practically impossible to find out sum of all the terms of the geometric progression, right? बट गाइज यहाँ पे क्या हो सकता है, सी यू स्टार्ट विद 729, उसका वन थर्ड हो गया, उसका वन थर्ड हो गया, उसका वन थर्ड हो गया, फिर 27 9 3 1, फिर फ्रैक्शंस आएंगे 1/3, then 1/9, 1/27, right? So as and when you increase the value of n, okay, the number of terms, the nth term will be practically close to zero, right? Okay, तो हम लोग क्या कर सकते हैं, हम लोग एक पर्टिकुलर लिमिट के बाद we can assume all the terms to be practically equal to zero, and in this case, in the case of a converging GP, you can always find out the sum of the n terms, okay? So guys, we observe that in this case, okay, if we take a fraction, let's say यहाँ पे अपना common ratio जो है 1/3 है, right? Okay, 1/3 is to a very large value, okay? Let's say अगर 1/3 को हमने square ही किया तो 1/99 हो जाएगा, value कम हो गया. इसको cube किया तो 1/27 हो जाएगा, right? So R, if it's a fraction, guys, observe that for a fraction, if you raise it to a very large value, it will be close to zero, isn't it? So guys, observe that in the formula which we have, a r raised to n minus 1, if n becomes huge, very big, okay, okay, so you are basically writing all the terms here, okay, all the possible terms here, right? Okay, so here the value of n is very huge, and that is why r raised to n will be basically a fraction which is very close to zero. So we are basically finding out the sum of the infinite terms of a converging GP. Okay, and for that, as I said, we just put r raised to n as 0. When you do that, you get a upon 1 minus r. Okay, so you can remember this formula, guys, for for a converging GP where the common ratio is between 0 and 1. Okay, then sum of the infinite terms is basically a upon 1 minus r. Okay, it is the most important thing which we need to understand in case of geometric progression. Okay, because यही चीजें आगे बहुत बार अप्लाई होती हैं ज्योमेट्री में भी, प्रोबेबिलिटी में भी, कुछ क्वेश्चंस में. So we'll see that